Hi everyone, this is Dr. Maxwell from the Department of Geospatial Science at Radford University, and today I'm going to be giving an introduction to the CDendro program, the partner program to CuRecorder that can help you with some of your data collection, analysis, and cross-dating. So let's go ahead and start out with opening up the program CDendro. I'm working with one of the newer versions, 9.6 from late 2020, but you will see some of the similar features in some of the older versions as well. So it starts out pretty plain. We have to begin with starting a new collection. So let me walk you through how to do that. We go up to the collections menu and we are going to create an empty collection. Just go ahead and title this test 1. And you'll see we have a blank collection menu open. The next thing we're going to need to do is load in some files. We're going to be loading in those .pos or position files that we have from the CuRecorder program where we've measured some samples already. So we can go to the collections menu once again. We're going to go down to the add collections menu here, and then we are going to select any Dendro files to add to this collection. And you could add .rwls as well, but we're going to be adding .pos files today from CuRecorder. So here I have a bunch of samples that I've measured recently from southwestern Virginia. This is an old growth white oak site that I'm still actually working on cross-dating, but many of the samples are in good enough shape to show you. So we'll add in all of those. And we've pulled in 47 samples. And what you'll see now is we've populated some of the menu here with some statistics and data about each sample. So here you can see one sample. This is ROW01A, and you can see that it has a start year of 1717 to 2018, 302 years in length. We got the file name and so forth. And then we can populate some of these other columns with some analysis that I'll show you. So this is the initial step. You need to get in some data to populate this. This is your collection. Now, one of the things I often start out doing is I'm just going to start out and save this. And so we're going to go up to the collections menu, down to save current collection. And there's multiple different ways to save this, but in the CDendro program, we are going to save a .fil or fil file. This is a list of the file names, and so it doesn't keep the data within it. It says it's pull these files into the collection from this storage location. So I'm going to save this, and we can just leave it called test1, named after our collection. And it'll be a .fil file. So we've gone and saved that, and now we have this data collection saved in at least one format. If you did want to save it and export it for use in another program, let's say you wanted your more standard .rwl collection, we can go to the collections menu here and then go down to save current collection, and here we could save it as the Tucson format. You can do Heidelberg, other types of formats. You can even save it in a more tabular format that you could read into R or a spreadsheet program like Excel. Now, you can do it with comments that has kind of the lines at the top that have metadata about the site, or you can save it without comment. So I'm going to go ahead and save it without comment here. And it gives you a couple error messages or warnings here about, do you want to write the header on there, because you could have some problems with Cophatia. However, I recommend that you kind of move on from Cophatia and maybe use DPLR or Andy Bunn's XData Shiny app. So here I'm just going to go ahead and hit yes. I'm going to save this just as test1. And it's going to give you another warning message here telling you about some of the members that may be included or not included in there. And if you look at that file, let me go and find where I just saved it. If we go ahead and look at it, we can see here the or the test1.fill, but we can also see that we have the collection here as an RWL format. And if we open that, kind of looks like your standard format. I don't have anything set in the header yet. So that's opening the program, pulling in data, and saving. But there are a lot of other features in here that can be very helpful to help you manage your data and cross-date. And so let me show you a couple of those features. One thing that you may want to do is make sure that you set your metadata. And so this box here, if we go ahead and click on it, it's going to pull up this menu. And we can go through here and type in site name. We can type in things like the country. We can put in the latitude and longitude. And what this box is going to do is it's going to create that header that is typical in that Tucson tree ring format, that decadal format. This way, when you're uploading data to the International Tree Ring Database, you have that metadata associated with it. And so that's what this menu is key for. I'm not going to fill everything out though right now. But you begin to see that it starts to fill out this area here. And you want to make sure that you have that appropriately documented. Now, we can look at some other nice things just to get a quick glance at our data. Over here, there's a button called Timeline Diagrams. And if we click on that, you can just kind of have a quick look at your sample depth, as well as look at basically the data stacked in terms of the segment length. And so in this collection, we have trees going back almost to the year 1600, and clearly you can see that these trees were recorded in the year 2018. And if you want to, you can copy this to your clipboard. You can save that file if you wanted to maybe just have a quick slide in a PowerPoint or kind of a quick documentation of your sample depth. Now, a lot of things that you probably want to do if you are looking to cross-date is get some quick numbers on the correlation of your measurements against a reference or a master chronology. And so what we'll do here is we can do what's called create a sample mean value. Now, we don't necessarily know how well these cross-date. These ones cross-date moderately. But we can create a sample mean from the group to begin getting at identifying any potential flags or errors in our dating. So I'm going to create this sample mean, and then I'm going to date all of the other cores against it. So creating the sample mean will open up a new menu. And so here it's going to call this menu reference. And what it's done is it's created kind of your average growth series, your time series. And it has similar kind of methodologies in the background to create it as an index and detrend it and standardize it a bit because of the nature of raw ring with data being in millimeters. And so we can see this is the growth series through time. The numbers here on the top represent the sample depth at a given year. And so in 1825, we have around 39 or 40 tree ring series. And as we go back in time, the sample depth begins to drop, and we've only got one or two going back towards the early 1600s. But we can take this reference and then date other trees against it. Now, if you are working in the Coup Recorder program, one of the things that I recommend doing is if you've measured, say, 5 to 10 series or 5 trees or so, two series per tree, you can create your own reference from that to aid in your dating. Now, you want to have trees that are pretty well behaved, don't have missing rings and things like that, or appear not to have them. And you can create a reference to begin dating those against. And you can do that by taking this reference that we've created and going to the samples menu here, and we can save the ring width data as a single column. And this is what's called a .wid file. And this .wid file is the reference chronology format that you would need to open up in Coup Recorder. And so you can see how I have other ones here that I've created in the past for this site. So I can save that .wid file, and when you go into Coup Recorder and you set your reference, that's the file type that you're looking for, .wid. Now, if we go back to the main menu here, the main collection menu, we can begin getting a look at how well these samples correlate to one another. So to do that, we can hit this Show Cross Correlations button. What this will do is open up this submenu, and you can change this however you'd like. This has a default of a 20-year overlap, looking at correlations between the master or reference chronology and each of the cores in the data set, and kind of looking at that through those 20-year time slices. It will give you a correlation coefficient, a t-test, and the number of years of overlap. And so you can go and customize these things similar to Cophagia or in DPLR. I'm just going to leave it as the defaults for now. If we hit OK here, you can see that we pull up, what's that still calculating here? It's going to pull up a window down here at the bottom, and it's going to show a correlation matrix. So the correlation matrix opens up down here, and it will show you the correlation between one sample and the rest of the data set. And so this gives you the correlation, the t-test, and number of years of overlap with the reference or master chronology. That's typically what you're going to see in XData, DPLR, or Cophagia. But you can also get the statistics that will show those correlations to each of the other series. And so if we wanted to look and see how well 01A and 01B correlate, we can do that. And this can help you identify which trees are kind of saying the same thing in terms of their ring list from one year to the next. So it can be somewhat helpful to look at this and to identify trees that are saying the same thing. You see here they're color-coded, the darker color meaning a higher correlation. So this is one piece of evidence that you can get to help you begin your cross-dating. It'll show you bad pairs, it'll show you trees that aren't well correlated with each other, and that may be some indication that you have some errors in dating, or it could be some indication that your site is more dominated by local disturbances and stand dynamics rather than maybe a climate dominated site. This is from the eastern United States, a closed canopy forest, and so some of these lower correlations are pretty standard for these sites. So that's one way to look at it. I'm going to pull that down so we can see our collection a little bit better. The next thing we can do here is hit test towards a reference. And if we test towards a reference, this will go and populate these three columns here. This is the correlation coefficient, the t-test value, and the years of overlap between the reference and the sample. And so here we can see this is for the entire overlap of the series of 301 years. So we have a correlation here of 0.54, a t-value of 11.1. That's probably fairly well dated for these oak trees. And you can click here and you could sort that. And so you can see which ones have very, very low correlations. Some of these may be dated, but just have a lot of stand dynamics, a lot of disturbances in growth, releases, and suppressions. You can also sort by t-test value if you'd like, years of overlap, and so forth. But this gives you some indication of how well you're dated. Now, one of the things that I do sometimes is I might go and uncheck all of these, and then if I'm sorting the data and I want to try to date against a master chronology, I could go through and maybe just select the best matching cores. And so you can do that either by going and clicking on individual ones and then saving that as a reference chronology, or we can hit select best matching members. And we can set the minimum correlation value that we might want to have included in there. So I could maybe put this at a 0.5 correlation and then run that. Actually, I'm gonna check them all and then hit this. Sorry, and then run that. And what that does is it unchecks these low correlation cores here. And then if I create a sample mean again, it has updated my reference from the previous tab. Then I could save this as a .wid file again, and that will help speed up some of your measurement and cross-dating kind of on the fly when you're in kuRecorder. And that's often what I do is start the site out, I begin measuring a number of cores, try to get 5 to 10 trees in there, 2 cores per tree. Then I create a reference from that. Then I can use that as I interactively measure and date in kuRecorder. Other things we can do here, if you test towards the rest of the collection, that's kind of similar as testing towards the reference. That's going to go and run those correlations and populate your table again. Now, you may have a large number of samples. Some of them might have low correlation, and so you could select to add your best members to a target collection and create a new target collection and put those in there. I tend to keep everything in the collection and then iteratively work through that process of cross-dating. Now, if you want to look at an individual tree, we could say pull out just the first sample here. And if you just highlight it with one click, but if you double click on it, it's going to open up a new window. And in this window, let me orient you to a few things here. In the top, you have 2 tabs for your workbench and your curve display. You can see here, this is the correlation, t-value, and the number of years of overlap is 301 years down here. Now, we could use this as a reference, but we don't necessarily need that because we have our own reference. But sometimes when you're trying to date samples, you may compare it to an A core to a B core and things like that. Let me show you kind of what's happening here. The reference chronology is the black with the standard deviation around it. The red line there is the series that we're looking at, 01A. And you can see here the sample size are these black numbers down here at the bottom that are used to compose that reference chronology. And so if you have poorer dating as you go back in time, maybe it's because you have lower sample depth and more noise in your reference chronology. It's a little bit difficult to look at it with all of these things on here, so I often go down here and unclick Show Standard Reference Standard Deviation, and then I can begin to look at that pattern of narrow and wide rings. So here I'm often looking for those marker rings, those really dry years, or occasionally sometimes those really large years to make sure that this is well dated. If you're kind of using a more visual approach, I recommend using this vertical rulers. And this way you can slide through and say, okay, well, what is that marker year? 1954. Okay, well, that is a regional marker year for this Southwestern Virginia site. Okay, great, it matches up. I'm glad to see that. And I might look through time at those marker years to decide that, okay, it's matching up in key positions like 1936 and 1954. But other things that we can do are look at some of these areas on the graph where it has these gray bars. This is showing areas where the data are pretty well correlated in that segment. Now, these segments are in 50-year block lengths, and it's just overlapping every 50 years as well. So it's basically just big 50-year blocks. So we could do 50 years and like a 25-year overlap and have that recalculate. And these values right here, 0.05, 0.74, that's showing the correlation between your reference and the core of interest during that time period. So this is pretty well dated in this section, but as we go back into the late 1800s, this is an area where these trees don't date very well. And you can see we actually have negative correlations. So this would then lead you to want to go and investigate your core in kuRecorder. Now there's an easy way to do it and transfer from one program to another, and we can inspect that. So I will go up to the top here and we can click on the kuRecorder button. This is going to open up the kuRecorder program and load up the image. So let me pull that onto this screen. So we can load up that image, and if we wanted to go and zoom in to the late 1800s and try to identify what's going on here. Turns out these trees are pretty complacent, growing very similar from year to year, and the dating is poor in this area. We could compare it pretty quickly to the reference chronology by enabling the ring width curve display and choosing our .wid file as the reference. And this will allow you to also have a good visual, as well as look at the correlation coefficients down in this bottom line with those segments of overlap. Now these segments of overlap here are 20-year segments, but you can change that too in some of your settings. So there's a lot to be kind of uncovered and discovered in the CDendro program, as well as kind of how the companion coup recorder works. I just wanted to show you a few options today with that, because some of this you might use just purely for kind of organizing and exporting and creating metadata for your collection. Other people will use this for a lot of their cross-dating. And so in a future video, maybe I'll show you how to use some of these techniques for cross-dating in here. Otherwise, often what I do is I do go to the collection, and I will save that collection as a ring width file, and then I'll open up DPLR or Andy Bunn's XDater app and do my cross-dating in there, because I'm familiar with that methodology. There are a host of other things in here. Most of this is for data manipulation, bringing in different types of data. So you could add to this collection .rwl files if you've maybe measured them on a Belmex and put them in this collection. You could also bring in other types of Dendro files into here. One other thing I will show you, let's say you have a chronology from a nearby site. Maybe I have a White Oak site from West Virginia, and I want to use it as a bit of a crutch to help me out and begin dating this. I can create a reference curve from a decadal file format, whether it's .rwl, .text, or so forth. And so you can then create a master or reference chronology from an existing site to help you date your cores either in CDendro or as you're measuring them in coup recorder. The last thing that I will show you here is in the settings menu, and you can look at and manipulate some of these settings. You might as well just dig in and see what some of these settings are. I tend not to mess with them too much unless I'm trying to cross date, but the one setting that I always check before I'm exporting my data is in the More Settings menu. And I look to see the decadal file measurement unit. I want to make sure it's at the precision of 0.001 millimeters, or the micrometer there, because this is basically just pixels, right? And so we want to get the highest precision as possible. You can also pull into here your seasonal wood measurements as well and create collections from those too. And that's a relatively straightforward process, similar to what I just showed you with the regular ring width measurements. So that's all I have for today. Hopefully this video gets you started in CDendro and helps you understand how its companion program, coup recorder, work together to help you measure and cross-date your samples. I'd say, and the last thing I want to emphasize is, don't just look at those numbers for correlation coefficients and t-values and think, oh, well, it's pretty high, it's well dated. You want to make sure that you really dig in and look at that dating across time in those individual segments, because while this has a 0.54 correlation, which may be acceptable for White Oak in a place that has a lot of stand dynamics, there could be still areas where there are dating problems and shifts need to be made, rings need to be inserted. So always go back to the wood. Don't just trust the statistics of the program, and that will make you a better dendrochronologist. And now I'm just going to go and do one final save of my collection as a .fill. I'm just going to overwrite that, and I'm going to include the unchecked members, but you could not include them. And that's it. This is the collection, that .fill file that you would open up, and then you can export in a variety of manners. So appreciate your time for listening to this. Hopefully it helps you out, and in the future I'll hopefully work on a cross-dating video in CDendro and perhaps in DPLR. All right, take care, everybody.